All right, we're live. So my name is Scott Hunter, and with me today I've got Aditi.
Hi.
And we're to talk, basically this talk today is about a day in the life of a modern .NET developer. And so that means we're going to go over a variety of things. We're going to talk about moving your applications to the cloud, lift and shifting a .NET Framework application. We're going to talk about a new Windows compatibility pack we have to make it easier for people to move to .NET Core. And I'm going to show some stuff about how you would actually build an app and take advantage of all the features that we have, CI/CD, Cloud Publish, diagnostics in the cloud, and stuff like that. Because this says it's a day in the life of a modern .NET developer, we don't expect everything to go perfect today. We're actually going to write code and do stuff, and this is not meant to be some crazy polished thing. To start off, let's talk about the cloud journey. When I think of the cloud, I think of a couple things. One is we think of all of us have had apps that ran on on-premise servers and virtual machines. And then as we start moving to the cloud, the first thing you do is you take those virtual machines kind of as they are and lift and shift them directly into the cloud in the form of IaaS. You get some benefits from doing that. The primary benefit there is you don't have to buy the hardware anymore. You don't have to actually deal with machines that break. You don't have to upgrade the hardware. But you still have to manage these things. And then there's what I would call the super nirvana, which is PaaS. And that's when you get to something like Azure App Service or microservices running on a PaaS platform. And in this case, you don't have to worry about operating system updates. You don't have to worry about hardware. You don't really worry about anything, even backups. That's all taken care of by the cloud. And we have a bunch of stuff in the case of .NET to help you along that journey. So first off, this is a slide we have from a book that Caesar on my team wrote. That kind of talks about the way that you would actually make this move. And typically what we kind of think is you would first potentially lift and shift your application maybe as a virtual machine, or you'll wrap your application in a container. Aditi's going to show that in a second. Move that to the cloud. One of the benefits of moving it into a container is it means that if all your old apps and all your new apps are all in containers, then your DevOps story is exactly the same for those. Once you actually move these things to the cloud, you're likely to greenfield new parts of your application using the latest tech that we have. You might be using .NET Core to build the newest APIs or the newest parts of your web app. And so you get this cool world where you have your older applications running as is in containers, and you have your newer applications running as is, obviously in containers, all in the same picture. And this is kind of the story that we have. And we have a whole we have slides later in a second that will actually show you where you can go to the dot.net website and actually download a book that shows you how to actually make this move. The next thing, we're going to move to Aditi. And the main thing we want to demo here is, for the last 2 years, I've been going around and demoing .NET Core and showing that, hey, .NET Core, you can publish your app to a Windows container, or you can publish your app to a Linux container. But the reality is .NET Core it only shipped last summer as an RTM. It's brand new technology. A lot of my customers today are actually building ASP.NET applications on .NET Framework, WCF applications on .NET Framework, and our goal is not to leave any of you behind. One of the things that we talk about, and we'll talk a little bit later in the deck as well, is .NET Framework's not going anywhere. It's a framework that is fully supported. We're still going to work on it. With .NET Standard, all our new APIs will actually be in .NET Core, .NET Framework, and Xamarin. And so we want to make it very easy. If you actually have an existing WCF or ASP.NET application on .NET Framework, you don't have to move to Core to get to the cloud. You don't have to move to Core to get to containers. And some of this is kind of painful today, which I think is going to happen in your demo. But this is one of the areas that we're tooling in Visual Studio over the next 6 months or so. And so I expect that by early next year, you're going to have first-class tooling in Visual Studio for taking an existing .NET Framework application, wrapping it in a container, and putting it in the cloud. And with that, we'll switch over to Aditi.
Sounds good. Thanks, Scott. So I'm going to take you through a demo where I show you a traditional line of business WinForms app that you might have on your computer. So if we launch this app here, we basically see a storefront, and you can manage the inventory for your web store. And you can say, okay, I want to see the inventory on a specific day for a specific product, or you can add a shipment here. And you can also control if you have a promotion going on, if there's a banner that comes up. So
let me just interrupt you for a second. One of the cool things about this app is you actually have already modernized the WinForm part of this, right?
Yeah, so I've modernized the WinForm part of this. I'm making the high DPI compatibility changes, and I'm also able to deploy it to the Windows Store using Centennial.
Yeah, so with the updates that we had in Visual Studio 2017 15.4, you were able to, we've done two things here. First off, your application, because it's using .NET Framework 4.7 or higher,
Exactly.
it's taking advantage of some of our abilities to take a WinForm application. We know that high DPI monitors are very popular now, and so it's been already modernized to work on high DPI monitors. And then we want to make it easy to install applications using the Windows Store. And so starting with 15.4, you can basically right-click on a project, wrap it in a store container, and then you can actually publish it to the store. So she's already done those steps. We're going to focus on the back end.
Exactly.
But I want to call out that there's already some modernizations happened here.
Exactly. So as Scott said, the next step in modernization is putting this in containers, deploying it to the cloud, and maybe even integrating some of the newer technologies that we have, like a web API, into this application.
Cool. Show us how it works.
So let's go with the containers first. So it's actually, for those of you who don't know a lot about containers, so containers are basically a lightweight solution to package a lot of your dependencies together and be able to deploy that across machines in a scalable way. This means that I can develop on the same image that I'm actually going to run in production, so I don't see any mishaps when I actually start running in production. It also means that I can take this app, I can build it, and I can give it to Scott, and Scott can download it on his machine. And if I have a SQL Server database in there, he doesn't actually have to have that installed already. He can just have that image pulled from the container, and that will be on his machine. And then when he's done, he can get rid of it, and it's like nothing has happened to his machine. So it's a really simple solution, lightweight and fast. And it's actually pretty easy in Visual Studio, which I'm about to show you. So if we go back to Visual Studio, the WinForms app is built on a WCF service, and it's built on a SQL Server database backend. And we're going to containerize the WCF service and SQL Server database. So all you have to do is right-click on your WCF service, go to Add, and say Add Docker Support. And this is going to create a few files for you. It's going to add this Docker file here in your actual project, and it's also going to create this Docker Compose file, which will be your new startup project here. So we're going to have to go and make some modifications to these files, so I'll go through them one by one. So first, in your Docker file, basically right now it's telling you we basically have this Windows Server image up on Docker Hub, and that's where this ASP.NET image comes from, and it's using .NET Framework 4.7. But what we're going to add in is to make sure it's compatible with WCF. So we add in some things here. So basically what we're saying is run, add web server, and we're adding support for TCP here, add support for HTTP, and then add WebSockets. And this is basically describing the environment for your application. And what's really cool is that I was able to do that in just a few lines of text. So instead of having to install things on a VM and having that be a lot more complex and lengthy, you were able to do it in just a few minutes by adding a few lines of text into your file.
You have to RDP into a VM and hand set it up. Now you just actually create the VM and set it up in a simple text file.
Exactly. Next, we're going to take a look at our Docker Compose file. So right now it has this image for the WCF service in it, and it's referencing that Docker file here. And we're also going to go ahead and add this SQL Server image here. So when I add this in here, that's now saying, okay, we want to pull the SQL Server image as well. So when you start up the project, it's not only going to pull that ASP.NET image that we saw before, but also the SQL Server image. And then lastly, we have to make a couple changes in our Docker override file. And this is just really to some environmental variables to make sure that we're talking to the WCF service properly. So now if we start Docker, you can see that it's building here. And the first time you do this, it'll probably take a while because you'll have to download and pull those images, the ASP.NET image and SQL Server image. But once you've done that once, it's actually pretty quick before it launches. Great, so here we see that we have this IP address, and if we start the catalog service here, now we have a running service. And all you have to do is now take this IP address and go back into your WinForms application in your app.config file. And before we were running on just a local host because our service and our SQL database were just running locally. And you can copy paste this IP address in and restart your WinForms app. And you should now be running with your service and your database in a container. Oh, there it is. So as you can see, it comes up. And now this is actually referencing the service and the database in the container. And you can check also that your containers are running by going to your command prompt, putting docker ps in, and you can see here that we have this first container, which is your WCF service, and then we have the SQL Server container. And you can also see a list of all your images here, and you could keep those or delete those when you're done, and nothing would happen. So now that we've deployed this in a local container, the next step would be to think about if we want to use a production orchestrator and actually deploy it to the cloud. So I've done some of that work in advance. You can do all of this through Visual Studio using VSTS. And I've done some of this work in advance and I've chosen Kubernetes as my orchestration provider. And as you can see here, I've set up a build and I've deployed both the SQL container and the WCF container to Kubernetes. So if we pull up this Kubernetes dashboard, you can see that both of them are deployed and are running successfully. We can even take a look again at this catalog service by visiting this IP address here. And the service starts successfully. And so all we would have to do again is take this IP address and plug it into that same connection string that we have in that WinForms app and relaunch the WinForms app, and it would run again. So now I've talked about a little bit about containerizing your app locally, deploying this through a production orchestrator to the cloud, and the last step would really be to integrate some new technology into this. So you can add something like a web API into your existing WinForms application. So this I've actually done a little bit of the work in advance here as well. So if you remember, you saw that banner at the top of the WinForms application, and it's basically a discount that you want to provide based on a date within the year. And you can actually move that discount service into a web API here. And all I've done here is I've referenced the Swashbuckle package to add a Swagger to this web API so that I'm able to call this from anywhere. And the cool part about this is once I've created this, I'll be able to not only call this from my WinForms applications, but if I have other applications like UWP, Xamarin, etc., I'll be able to use the same API and call it from there. And so now I've added Swagger support here and made sure I'm using Swagger. And if I go back to my WinForms application, I can, instead of calling it from the service, I can call this discount from the web API that I created instead. And when I launch this, you can say it's changed slightly a little bit to what's in the web API, because it has a little bit of different data here, but it also successfully works. And yeah, so those are 3 of the steps that you can take to modernizing some of your traditional apps. Once again, we deployed it to a local container. We then chose a production orchestrator and deployed it through Kubernetes to the cloud. And we also added a .NET Core Web API into it.
Cool. Cool. Thank you. So we'll switch back to me. And let's talk about moving to .NET Core. So just a couple weeks ago, we shipped the 15.3 release of Visual Studio 2017, which included .NET Core 2.0, and it included something else called .NET Standard 2.0. As I mentioned before, one of our goals in the .NET team is a lot of our customers out there, maybe people listening, all think that, hey, because .NET Core is the newest thing that we built, everything's going to move to .NET Core. And the reality is there are plenty of reasons to still have .NET Framework. All of our traditional Windows workloads, WinForms, WPF, WCF, and ASP.NET are built into .NET Framework. A lot of those are built into .NET Framework because they are Windows only. .NET Core is a cross-platform version of .NET. It cannot carry with it the Windows-only components. And so we're always going to have a version of .NET that is focused on Windows Desktop, and that's .NET Framework and Windows Server. We also have Xamarin, which is our flavor of .NET for building mobile apps that run on iOS and Android. And so I don't see a point in the near future where we're going to take all three of these .NETs and convert them into one. So the idea that you have to move from .NET Framework to .NET Core is a fallacy. The reality is what we've been preaching is we want all of our customers, all of our library authors to build all their libraries on what we call .NET Standard. .NET Standard is a common set of APIs. It's a spec. We basically wrote a spec saying, here's all the APIs you must implement to be in .NET Standard. And we make sure that .NET Core, .NET Framework, and Xamarin all implement all these APIs in this spec. This means now you can easily share code across all of our libraries. So if you're JSON.NET and you write a .NET Standard version of JSON.NET, it's guaranteed to run on all the .NETs that implement JSON.NET. That means .NET Framework, .NET Core, and Xamarin. And so this is how we will still invest in .NET Framework. As we add more APIs to .NET Standard, they will move into .NET Framework, and they'll move into Xamarin. So you'll get those no matter where we start. Maybe we'll prototype something in Core, because it's easier for us to do that, but it will eventually land in all those places. And that's .NET Standard. What we're really happy to say is with the .NET Core 2 release, we introduced .NET Standard 2.0. Some of the feedback we got from customers as they were trying to move to Core was there was too many APIs missing. So we added basically 20,000 APIs back. 70% of all the NuGet packages in NuGet.org are compatible with .NET Standard 2.0, which means you can use those NuGet packages across all of our .NETs. With the RS3 release of Windows Client, we've added .NET Standard 2 support for UWP as well. So if you're a UWP developer and you were frustrated by some of the classic .NET APIs being missing, they're all back with the RS3 release. This is just an example of some of the stuff we brought back, all of our data, all the XML, all serialization, all networking, I/O threading core, lots of good stuff. It's been shipping for a while, and so I think you're going to really enjoy it. Now that said, something else we've noticed is there are some customers that really want to move to Core. Maybe it's because they want to use MVC Core or ASP.NET Core, which contains a new version of MVC with some new awesome features around diagnostics and dependency injection and Razor. And if you want those features, you have to move. Maybe that's a reason to move to Core. We're going to make it even easier to move to Core. We actually have what we call a Windows compatibility pack for .NET Core, which brings back some of the Windows-only APIs for .NET Core application. These things like system configuration, system drawing, system registry. These are obviously Windows things, and I'm going to demo some of that in a second. So I'm going to jump to my machine, and as I said before, this is a day in the life of a .NET developer, and so I can't promise all this is going to work, but I'm going to show a bunch of new stuff. So I'm going to build a ASP.NET Core application. We'll just select that. And what I'm going to do is I'm going to use our MVC for ASP.NET Core, and I'm hopefully going to show some stuff you haven't seen in a while. So there's this change authentication button. A lot of web applications want you to be able to log in and create a profile. We actually build this into .NET. And so I can come over here and say, hey, I want individual accounts, and I want to store them inside of my own application. That means I'm going to store them into a database. So I'm going to click OK here. And we'll click OK again. And it's going to build my application. So once this app builds, I'm going to run it and run you through some of the things that might happen here. So my app's here. And let's just run this thing and see what it does. So I will go up here, start without debugging. Give it a sec to boot up. As I said, because I chose that individual accounts, that means this app's going to have a register and a login field at the very top right of the application when it boots up. So here you go. I've got my register and my login. So we're building this for you. So I'm going to log in. I'll just make up an email address and a password. Click register. And what happened is I get a failure immediately because I never created a database. And one of the features of NED Framework is it has the ability to create what we call migrations. And these are our C# code that defines how you would actually create the database. And you can see it's saying, hey, there's a migration that needs to run called create identity schema. So I'm going to click apply migrations. This only occurs, the apply migrations button only happens when you're actually in development mode. So if I'm running this in production, you would just get an error on the page saying the database doesn't exist. But in my case, because I'm running in developer mode, it's going to let me actually just right from the web UI create the database. And now it says try refreshing the page. We'll continue here. And now I'm logged in. Great. Now, most websites, when I log in, I have a place where there's like a photo of me on the website. I can put my profile photo up. And so I was looking at this and I was going to go, man, I want to add that to this application. So let me show you how to do that and show you some of the cool features in the product as part of that. So let's go back to the IDE. And the first thing I need to do here is I've got my model folder. And anytime that you actually say that you want to have user accounts in your application, we create this application user. In the past, with the membership system that we had in .NET Framework, it was very rigid and it was hard to add new properties to this. So in my case, what I want to do here is I'm going to go to this application user, and whatever fields I add here, we will store in the database. So I'm going to say prop, and I'm going to do a byte array, and I'm going to call that photo. So that's where I'm going to store my photo. So now I've got a photo property on my database. Great. What's the next step for me to do? The next step is I need to go add that to my database. And traditionally what you would do is you would maybe go into SQL Management Studio and add this, or you'd go in there and write a script or something. But I'm going to use the power of Visual Studio and the power of NED Framework to do this magically. So I'm going to go grab the folder of my application. Going to go in that folder. And once I'm in there, I can actually run, via the .NET command, I can run things like .NET EF migration, and migrations, and I can say add photo. And so what this is going to do is it's going to analyze my app, analyze my database, figure out what the differences are, and write some code to fix this. So we'll give this a second here to run. As I said, it's going to basically look at my project, look at my database, and do the magic to do the conversions here. There you go. And if I go to my application in the data folder and I open this migrations folder up, there will be a photos migration. And inside of that, I can see the C# code written to basically add the column that we're talking about. It's pretty slick. Now, all I've got to go do is go back to my command prompt and I can say .NET EF database update. And what this is going to do is it's going to go look and find out what last migration actually ran on my database. And it's going to run all the migrations that have been created since then. And so in this case, it's going to run that one migration to add that column to my database. So there you go. So now I've got a column added to my database. And now I just have to go add to my application the ability to actually upload the file. So let's go here. We'll close that down. And I'm going to stay in my model folder because in the case of this application, I have a page called the index page when I look at my profile. And this is the model that is the form that makes that up. And so all I've got to do down here is add a new field for the upload. So let's call it an iForm file, call it photo, and we'll do get set. And I'll make it public. And this will be the backing field in the actual web UI that maps to that database. Can I type? Just use, there we go. So I can compile again, and I'm good. Now all I've got to do is go add to my form the HTML to make this work. So we'll go to our views folder, we'll go to manage, and I'll bring up the index page. And so you can see on this index page, there's my username, there's my email, there's my phone number, and all I'm going to do, I'm going to cheat here a little bit. I'm just going to go and grab this phone number. And we'll change this to say photo. You see IntelliSense is helping me here. It knows what's on my model. Pretty simple. So all you've seen so far, what I've done is I've added the field to my database. I've added the field to my view model. I've now got it in my HTML. And the only thing left for me to do now is go to my controller and actually add, let's close a little bit of this down, go to my controller and add the support to save that to the database. So in my controller, I'm going to have there's my index page where it takes the model. This is a post, which means this is when somebody presses the submit button. So I'm just going to write some simple code down here to say, here we go, if the photo, let's do model photo, if the photo length, meaning that there is actually something there, the user actually has uploaded a photo, is greater than 0, then what I'm going to do is I'm going to need a memory stream here. So var memory stream equals new memory stream. This is, I have to have some place to store the, I need to get those bytes out, and so I can actually put them into the database. Bring in the missing using statement there. And now what I want to do probably is I want to copy the data from the photo. That we have. I will copy this into the memory stream. We'll do a copy to async memory stream. There we go. And so this is going to basically take the photo, convert it into bytes, and then I can basically say model, actually we take my user object, user.photo equals memory stream dot to array, converts it to the bytes. I've now got this, and now I need to tell the user manager to update the user. I'll do it async as well. Pass that, call await. Okay, so at this point you can see it's not many lines of code. I basically, adding a file upload to ASP.NET Core is really super simple. Grab that photo, put it into memory stream, then copy it to the user profile, and then update the user profile. So now, if I ran this, and let's do that, I'll go add the photo. Go back into my profile here. Look here, here's my new photo UI down here. I will click a photo, and I got an exception. Oh no. Let's see here. I actually did this on purpose. So this is actually something I found a couple days ago when I was hacking around trying to build one of these things. The issue is there was no photo, and my code's expecting photos. And that's because if you're in HTML and you actually want to do a file upload, your form has to support a different encoding type. And so I can set this to form multi-part data. And so this change up here enables my form to actually support uploads. Now what's cool is, because when I ran into this a couple days ago, I actually asked my team, I'm like, why don't we squiggle the form when we know that you've actually added an input type equal file down here. I have to make one more small change down here as well that I didn't do, is my input here, this should be type equals file. And so in a future updated Visual Studio, we'll actually see if you have an input type equal file, and we'll update this for you on the fly, or give you a squiggle to let you know that there's a problem here. So now, if I run this again, we should actually have success. Do a photo. We'll save it. Your profile's been updated. Now that's kind of boring. Even though the profile's updated, I can't see anything because I didn't actually display the photo. So let's quickly modify the app to actually display the photo. That's pretty simple to do as well. So what I'm going to do is I'm going to go to my home controller because I want this photo to be available everywhere. And I will create a new method here that lets me return the photo. And so let's do this. We'll do async because that's the cool way that we're supposed to do things. We'll do a task of action result. And we will call this thing get thumbnail. Pretty simple. Now, the next thing is that photo is stored in my user, and I don't have access to the user in my controller. So what would I do? One of the cool features that we have in MVC or ASP.NET Core is if I go to my startup file, you're going to see that we have dependency injection set up in this application. And so in here, you're going to see there's a whole bunch of stuff here that adds identity to my dependency injection. And because of that, I can basically just grab that user object and have it injected into my controller. So I can actually cheat a little bit. I can steal this from the managed controller here. It does this exact same thing. So I'm just going to go grab this code here. We're going to stick it over in our home controller. So what we're going to do is we're going to dependency inject the user manager into my controller. And I'll just fix that. And that will give me access to that user right from here. So now I've got to add a constructor. And I can make that constructor take this parameter. Dependency injection will just inject that into my app. I'll call this user manager. And then what down here we can do is we can say under user manager equals user manager. And so now my controller has access to the user. Good. So we're further. I'm still complaining because I have not actually finished writing the code here. And so next what I'll say is I want to get that user. And so we'll say under user manager, get user async. And we'll pass in the user object that we already have in the controller. And we'll add an await here. Okay, so now I've potentially got a user, and I'll write some code that says, hey, if I actually get a user, they're not equal null. And I might actually want to do more than that. I want to say if the user is not equal null and the photo that would come with the user is not equal null. So I know I've got an image at this point. Then I would do something. Else I would do something else. And I found this code to be pretty simple as well. I was kind of surprised when I was, sometimes the product surprises me. We've actually learned a lot over time. And so I'm just going to return what's called a new file because this is kind of a file format. And I basically just pass the photo like that because it's array of bytes. And then I have to give it a type of what am I going to return. So I'm going to say this is going to be an image, this is a content type, and this is a PNG file. So that's good. Good there. And then if I don't have an image for somebody, typically what you would do is return a blank image. So and I've actually stuck a blank image in my project already, and I would just do url.content. And I can give it I'm going to stick something in probably in my www.root, and I'm going to specify that in my image folder, and we'll just call that blank.png. There we go. And now once again, I need to specify the content type. At this point, we're pretty close to having this running. And I'll show that Windows Compat Pack. So there we go. This should all compile again. And so the final thing that I need to do is I need to go add a reference to this image in my views. So I'm going to go to my views, and I'm going to go to shared because I want this to actually be everywhere. So let's close that out. I'm going to go to shared here, and I'm going to go to, there's a login partial. So if you're logged in, we show this UI, and all I've got to do here is add a new LI. I'm going to put all the source code in GitHub today, so if folks want to actually go grab this, it'll be available for anybody to grab. And so I'm going to say, yes, I want this to go to my home, and then I want to go to get thumbnail. And so this just says this is the URL for the image. And at this point, I should be good. I basically added a new method that returns the image. I've added the HTML. So let's try this one more time. Now, the only thing wrong here is, man, my image is really big, and it took over my entire screen. This is where the Windows Compat Pack comes to play. So let's close that out. And I wrote some code years ago at Microsoft when I was working on something called Dynamic Data for resizing images. And I've got that library right here, so I'm going to drag that into my application. Because what I need to do is I need to resize that image to a thumbnail size. So let's drag that in. Yep. And let's compile. Uh-oh. Lots of things are wrong here. That code I wrote a long time ago was based on system drawing. I wrote some cool libraries on system drawing for resizing images, and now I'm kind of stuck in this weird state where I don't have the ability to call that because I'm a .NET Core application and that's a Windows-only API. But we just announced yesterday, or released the first public release of, something called the Microsoft Windows Compatibility NuGet package. So I'm going to grab the name of that. That will basically bring a bunch of namespaces, including system drawing, into a .NET Core application. So let's go back to the IDE. Let's click Manage NuGet Packages. We'll browse. Let's type that in. There it is. And I will install this. Click that scary-looking dialog box. And I'll wait for this NuGet package to install. And this is kind of cool. This brings back system directory services, system drawing, brings the registry in. So if you have some code you want to port to core, and there's some Windows components that you use and are missing, this is going to help you do that. So if I build this again, I should have a successful build. Good. So I got to make one final change. Let's go back to our home controller. And what I'm going to do is normally I would actually store that in the database, but since I should actually store the thumbnail in the database versus the entire picture. But I'm just going to write the code right here because I'm cheating. And so let's go look at that code. I'm pretty sure that in that image file, let's go look at imaging. There's the namespace, DB Imaging API. Go back to my controller. Imaging. And once again, I'm going to make all this available in GitHub, so you'll be able to grab and use my same code for resizing. Let's maybe make this 50 by 50, and we need to give it an image format, system.drawing.imaging.image format. And we'll say we want to ping. Good. Okay, so now I've added some code here that's going to rescale that image. So we should be good. In a real production app, I would actually do scaling and other stuff like that. I run this again. There's my scaled image. The screen doesn't look all messed up. So in what, 15, 20 minutes, we basically went from nothing to being able to add a new column to a database, being able to add it to the view model, modify the HTML, write a simple API to return it. Very simply to turn this app into a pretty cool app. I want to show one final part of this, and we're going to move on. If I wanted to, I can then take this exact app as it is and publish it up to Azure. And notice that I actually created a database. And so one of the things that people aren't aware of, because it's kind of hidden in the UI, is as this kind of fills out here, I can go to services, and I can actually add a database here. And I'll just say CSH, we'll do a new one. Sure. So there you go. At this point, if I then said create, this will actually create my Azure web app. It will create my database. It will wire the entire thing up in the cloud. And everything as I ran it here will work in the cloud. So it is that simple to build an app, and we'll publish and create all the stuff in the cloud for you. So that is building a photo thumbnail version of our template. So let me jump back to slides, and I'll do one final demo after the slides, and we will take a couple questions. So the next thing is, Aditi earlier was talking about modernizing an application. So we have a part of our website called www.dot.net/architecture. And this is where what the patterns and practices team used to do is all made available from our team now. So we have a bunch of ebooks up here, and you can see this. We have one which is about microservices and Docker. We have one about migrating to the cloud. This is the lift and shifting that Aditi was showing earlier. We have one just about deploying to Azure, building web applications, Xamarin mobile applications, and UWP applications. These are all rich books that you can download or view online. Most of them have a sample app. In fact, all of them have a sample app in GitHub you can download and run. And especially the migrate to the cloud, if you want to repeat what Aditi was showing, it's going to have some of the stuff about how to set the CI/CD and those things up for running Windows containers in the cloud. So please go here. There's lots of great information here for building your apps. Obviously, the next thing is, we like to say with Azure, I was just showing a sample just a second ago, all the flexibility that we have, that I had a SQL database, but you can see here, I could have easily done a Mongo database, or I could have done it in a container. We basically, that's the power of the cloud is all this OSS that we have, some from me and some from the third parties. It's all up there, and you can build great, .NET apps that take advantage of all that stuff. Another cool thing today was we announced yesterday, I think, that Steel Toe. Steel Toe is part of Java Spring. It's an ability for building microservices on Java, and it's popular enough in the Java world, that some folks that use Java love C#, and so they actually built a smaller version of some of the stuff, the Spring stuff, for .NET. And so this is basically a microservice platform on top of .NET, all built to work in Cloud Foundry, which you can then run in Azure. And so the cool thing is, you can see there's a bunch of features in this. It's a cool library. They're now part of our .NET Foundation, and so they're one of the big companies that we'll look at. They're joining other companies like Samsung, Google, JetBrains, that all are part of our foundation. So super cool to announce that. Let's skip through some of this. Let's talk about modern web development. So ASP.NET Core is one of the fastest web frameworks on the planet. If you look at Tech Empower, that's a public benchmark. We don't actually write any. We don't run the benchmark locally. We do run it locally just to test ourselves, but it's run by independent third-party people, and it measures the performance of web stacks. And you can see that it compared to Node.js and Java servlets, the .NET Core does super well in this benchmark. We're working on other benchmarks in their benchmark lab as well. There's ones around JSON, there's ones around databases. But one of our goals as a team is to make sure that .NET remains one of the fastest platforms for building web apps. Also, as part of .NET Core 2.0, we shipped ASP.NET Core 2, which contains a new feature called Razor Pages, which is a simplified version of MVC. It has another cool feature built into it. One of my favorites is Azure Diagnostics. You can basically build an app, publish it to Azure, and just view streaming logs and stuff right from the cloud with no configuration inside your application. With the 15.5 release that's coming pretty soon, we're adding a feature where you can actually set production snap points. This is, I want to debug my app live in the cloud, but not have it stop. that is built in and will be built in the 15.5 wave that's coming. We have Angular and React templates. We know lots of web developers want to build apps using AngularJS or React, and so we built customized templates right into the product for building a Angular React app that has a .NET Core backend. That same authenticator stuff I was just showing before, those auth templates, we have support for those for authenticator apps. If you just want to scan a barcode with your smartphone and then require the code to log in, we've got that. There's also great support for CI/CD in containers. You can build an ASP.NET Core app or an ASP.NET app, and in just a few clicks, have it running up in the cloud every time you commit your source code. So I've got one demo here left, which is demo modern web development, and I'm going to cheat a little bit on this one. So, so what I've got here is I have an app. Let me just go load the app up. My source folder, I have an app called Web App Snapshots. So let me unload my VS here, and I'll load up Web App Snapshots. And so one of the biggest challenges we have as web developers is when you're developing locally, it's easy to look at the machine and attach a debugger and all those things. When you get an app actually running in production, it's not the same kind of thing because harder to touch the cloud. I don't want to touch the cloud and stop the running applications. And so we have a cool feature that we can build into our web applications. And I'm going to show how this works. I'm going to go look at Manage NuGet packages. And you're going to see that what I've done is I have a package called the Microsoft Application Insights Snapshot Collector. So I add this package to my application. And once I do that, I publish it up to Azure. I have to make a small series of changes in my code, and I'll make sure these links are in the deck. I've got a link to it right here. Debug snapshots on exceptions in .NET applications. This is an article that tells you how this sets up. But the basic premise here is I can then go to the portal in Azure when my app is running, and I have a couple of these here. I can go up to that portal, and I can go look at my app and say, this is actually App Insights that I'm going to bring up. Go bring all resources up. I'm going to go to my App Insights node, and I'm going to look at my app map for my app. And this is going to show how my app is actually put together. It's going to show a map that shows here's my web app, here's some of the profiler running on the back end. What happens is with that NuGet package, we actually add a profiler to your app. And it's really cool because typically, how are you going to find out where the problems in your app are? You're going to go look at log files and stuff like this. This actually gives you a simple view of where the most common crashes, the most common slow parts of your app are. If I go then look at the app, it's going to show me the full exception that happened here, and I have this ability to open a debug snapshot. You're going to see this will take a second. I can even download this snapshot into Visual Studio. Now this is where I cheated. I knew I was going to run out of time today, so I actually downloaded one of these already. So I'm just going to go to my downloads folder. I've got my app in Visual Studio. I'm going to go to my downloads folder right over here. And I've got this snapshot I already downloaded from the website. And if I double click the snapshot, I can open it. I can attach my debugger. And what happens is it took that crash that happened in the cloud, and now you can see right in Visual Studio, just like you were if you were debugging locally, here's the crash, here's the exception. I've got the entire call stack available here if I move my cursor over here. So it really is kind of, this is what we think the future of debugging is, where you can basically find the exceptions right from the cloud and then develop and debug them in Visual Studio just like you would in a normal running application. So I'm going to stop with that. We'll go back to slides real quick. And we'll talk about a few customers and then maybe ask a couple things. So this is a couple of our marquee customers for .NET Core. A company called Raygun that builds some awesome diagnostic tools. They moved part of their application from Node.js to .NET Core, and they saw their throughput increase by about 2,000%. Super cool customer. This is another one that is a cool company called Astro Reality, and they use .NET Core cross-platform to basically put the moon in your hand. You can actually view the moon. This is an awesome one. Julia talked about this yesterday. This is Tencent. They provide the payment model behind WeChat, and they do millions of transactions a day in a cross-platform .NET Core application. And then UPS. They use .NET Core as well for a lot of their stuff. They use Xamarin for their phone apps, and so they're a big cool customer of ours as well. And I've got a lot more. So .NET is alive and well and doing really well. And with that said, I can answer a couple of questions real quick. Is the source code available to play with? And the answer will be yes, it is. I will make the source code for both the photo thing that I did available on GitHub later today, and I will make the debug snapshot source code available as well for people who want to see that. I did look at the questions that were asked earlier, and I wrote a couple of them down. One of them was, do we have a plan to do SQL Server reporting services for .NET Core? And that's a great question, and all I can say is we had a great control that worked in web forms. There was the ability to wrap that control so you could actually use it in MVC on the .NET Framework. But we have not yet explored how to do that with .NET Core, but it's something that's definitely on my list of things to do. The next question was, there was an ask earlier about what is the cost of Docker versus the cost of using IaaS. That's actually a hard question to answer, and I'll explain. So if you're doing IaaS, you can run a lot of things on a single machine. If you're going to do Docker, you have a couple of choices. If you're doing Docker and app services, you can do that single machine as well. You can basically just build a .NET application and publish it to Docker in app service, and you're going to basically have the same kind of pay model that you would have for a web app running in app service. Where Docker gets a little more interesting is if you're going to run something that has an orchestrator. You were showing today Kubernetes. In the case of Kubernetes, you're going to have one virtual machine that's kind of the orchestrator that's managing the rest of your virtual machines. And so you might have an initial cost where you're paying for one additional virtual machine. But I think once you break your app into smaller pieces and you're running multiple of those inside of the orchestrator, you're going to find that you can run lots of little microservices across single VMs. So you're going to get an economy of scale where you're running multiple containers inside of single machines. And so I think if you're doing one container, I would look at app service. If you're looking at more than one container, I would look at something like Kubernetes, which runs that thing. With that said, I think that was the last question that we had.
Yep.
So thank you guys.
Thank you.
Have a great Connect and enjoy the next show.